So in this video, we're going to tackle about the different differentiation formulas. By the way, there are 9 differentiation formulas, starting off with the derivative of a constant.
If f of x is equal to c, and c is a constant number, therefore f of x prime is equal to 0. Let's try some examples. Let's say f of x is equal to 1 over 5. We all know that 1 over 5 is a constant number. Therefore, f of x prime is equal to 0. Next examples. F of t is equal to 10 raised to 2. 10 raised to 2 is a constant number. Therefore, f of t prime is still equal to 0. Last example.
The derivative of x is equal to,
And the quantity of square root of pi is a constant. Therefore, it is equal to 0. Next differentiation formula is the derivative of a power function. F of x is equal to x raised to any number denoted by n. We can transfer n to the coefficient and subtract the exponent by 1. So it's gonna be f of x prime is equal to n x raised to n minus 1. For example, let's say f of x is equal to x raised to 3, or x cubed. First step is to transfer 3 before the x. So it's going to be 3x, subtract the exponent by 1, so it's going to be 3x squared. Next example. F of x is equal to 1 over x raised to 3. Note that we can transfer x cubed to the numerator. So it's gonna be x to the power of negative 3. Then solve. Negative 3x, then subtract by negative 1, so it's gonna be negative 4. Let us transfer it here. I'll rewrite it. Negative 3x to the power of negative 4. Negative 3x to the power of negative 4 is over 1. We can transfer x to the power of negative 4 in the denominator. So we can rewrite it as negative 3 will remain in the numerator, so it's gonna be negative 3 over x to the power of 4. Last example.
the derivative of x is equal to,
The quantity of cube root of x. We can rewrite the cube root of x as x to the power of 1/3. Then solve. 1 over 3 x and 1 over 3. When subtracting fractions, we can copy the denominator, so it's going to be 1 over 3 minus 3 over 3. So 1 minus 3 is equal to negative 2, then copy the denominator. So it's going to be 1 over 3 x to the power of negative 2 over 3. Note that we don't want a negative exponent, so we can transfer it in the denominator. So it's gonna be 1 over 3 x to the power of 2 over 3, or 1 over 3 cube root of x squared. That's it. Next differentiation formula is the derivative of sum and difference of a function. If h of x is equal to f of x plus g of x, plus or minus, therefore h of x prime is equal to f of x prime plus or minus g of x prime. Let's work on some examples. Let's say f of x is equal to 2x minus 3x to the power of 4. We have two terms here. Let's work one at a time. The derivative of 2x is 2 minus the constant 3 and find the derivative of x to the power of 4. So it's gonna be 2 minus 3. Find the derivative of x to the power of 4. So it's gonna be 4x, then subtract the exponent by 1. So it's gonna be 4x cubed. Then follow PEMDAS. So it's gonna be negative 3 times 4. So 2 minus negative 3 times 4, which is equal to negative 12x cubed. So the answer is 2 minus 12x cubed. Next example. Let's say f of x is equal to 4x squared minus 3x. Still, we have two terms. Let's work on the first one. So 4 times the derivative of x squared, which is 2x, times the derivative of 3x, which is 3. Then multiply. So 4 times 2x is equal to 8x minus 3. That's it. The fourth differentiation formula is the derivative of sine and cosine functions. Let's say the derivative of x is equal to the quantity of sine x. The derivative of sine x is equal to cosine x. Then copy the derivative of x. So it's gonna be parenthesis x. So cosine x times the derivative of x, which is equal to 1. You might ask why the derivative of x is equal to 1. We all know that x has an imaginary exponent of 1. Then transfer 1 as the coefficient, then subtract the exponent by 1. So it's gonna be 1x to the power of 0. And x to the power of 0 is 1. What remains is 1. Just like 2x, the derivative of 2x is equal to 2. The derivative of 3x is equal to 3. The derivative of 10x is equal to 10. So, cosine x times 1 is equal to cosine x. Next, the derivative of cosine x. The derivative of cosine x is negative sine x times the derivative of x. So negative sine x times the derivative of x, which is equal to 1. Therefore, negative sine x times 1 is still negative sine x. Next differentiation formula is the derivative of exponential and logarithmic functions. Let's work on some illustrations. The derivative of x is equal to, and the quantity of e raised to x is equal to copy what's in the parentheses, so it's gonna be e raised to x, then find the derivative of what it's being raised to. In this example, it's being raised to x, so find the derivative of x. So e raised to x times the derivative of x, which is equal to 1, is still the same as e raised to x. Next,
The derivative of x is equal to
the quantity of a raised to x is equal to a. Still copy what's inside the parentheses. And find the derivative of what it's being raised to. Then multiply it by ln and copy a. Note that a can be any number greater than 0. So a raised to x times the derivative of x, which is equal to 1, times ln a is the same as a raised to x ln a. Let's work on some more illustration.
the derivative of x is equal to
And the quantity of ln x is equal to the derivative of x. It's gonna be the derivative of x over, and just copy x. So it's gonna be the derivative of x is equal to 1 over x. That's it. Last,
the derivative of x is equal
and the
to
quantity of log base a x is equal to the derivative of x over, just copy x ln, then copy what's base or a, so it's gonna be a. So the derivative of x is 1 over, then copy the denominator x ln a. That's it. Next differentiation formula is the derivative of a constant multiplied to a function. If we have a constant c and a function, we can multiply it directly if you can already find the derivative of the function. So let's work on some illustrations. F of x is equal to x to the power of 5 over 3. We all know that there's an imaginary 1 there, so it's gonna be 1 over 3, and that's the constant. If we're going to extract 1 over 3, what remains is x to the power of 5. So 1 over 3 times the derivative of x to the power of 5, 5x to the power of 4. Since it's multiplication, we can directly multiply. So it's gonna be 5x to the power of 4 over 3. Next example. Let's say g of x is equal to 2 times the 4th root of x to the power of 3. 2 there is the constant. So 2 times, we'll rewrite 4th root of x to the power of 3 as 2 times x to the power of 3 over 4. So, we'll find the derivative of x to the power of 3 over 4. 2 times 3 over 4 x, subtract by 1, so 3 over 4 times copy the denominator, 4 over 4, so it's gonna be negative 1 over 4. So that's our exponent. 3 over 4 x to the power of negative 1/4. Then we'll multiply directly since it's a fraction. 2 times 3 is equal to 6x to the power of negative 1/4. Over 1 times 4 is simply 4. We'll rewrite it. We can transfer x to the power of negative 1/4 in the denominator. So it's gonna be x over 4 times x to the power of 1/4. Or we can rewrite it as 6 over 4 times the 4th root of x. We can also simplify it. Since the numerator and the denominator is divisible by 2, so we'll divide it. So it's gonna be 3 over 2 times the 4th root of x. Next differentiation formula is the product rule and differentiation. If h of x is equal to f of x times g of x, therefore h of x prime is equal to f of x times g of x prime plus g of x times f of x prime. Let's work on some illustration. Let's say the derivative of x is equal to the quantity of x times e raised to x is equal to copy x times the derivative of e raised to x plus copy e raised to x times the derivative of x. So it's gonna be x is equal to the derivative of e raised to x is the same plus e raised to x times the derivative of x, which is equal to 1. So x times e raised to x is equal to x e raised to x plus ex. Next example. Let's say the derivative of x is equal to the quantity of x squared times ln x is equal to x squared times the derivative of ln x plus copy ln x times the derivative of x squared. So x squared times the derivative of ln x is equal to 1 over x plus copy ln x times the derivative of x squared is equal to 2x. Then we can cancel x, so it's gonna be x plus ln x times 2x is equal to 2x ln x. That's it. Last example. If f of x
is equal to the quantity of 2x plus x cubed times the quantity of 3x squared plus 4x. Let's find the derivative. So first, we need to copy the second term, which is 3x squared plus 4x. Then we'll multiply it to the derivative of the first term, which is 2 plus the derivative of x cubed is 3x squared, plus copy the first term, which is 2x plus x cubed, multiplied to the derivative of the second term, which is 6x plus 4. Then, we'll FOIL it. 3x squared times 2 is equal to 6x squared. 3x squared times 3x squared is equal to 9x to the power of 4. 4x times 2 is equal to 8x. 4x times 3x squared is equal to 12x cubed. Plus 2x times 6x is equal to 12x squared. 2x times 4 is equal to 8x. X cubed plus x cubed times 6x is equal to 6x to the power of 4. X cubed times 4 is equal to 4x cubed. Then we'll look for some common factors by looking at the exponent. So 9x to the power of 4 and 6x to the power of 4 will add it. It will result to 15x to the power of 4. (12x cubed and 4x cubed). If added, it will result to 16x cubed. Next, 12x squared and 6x squared is equal to 18x squared. Lastly, 8x and 8x is equal to 16x. So that's our derivative. Eighth differentiation formula is quotient rule for differentiation. If h of x is equal to f of x divided by g of x, therefore h of x prime is equal to g of x times f of x prime minus f of x minus g of x prime, all over g of x squared. Example, h of x is equal to sine x over x. So that is our f of x, and that is our g of x. So, x times the derivative of sine x minus sine x times the derivative of x, all over x squared. So x times the derivative of sine x is cosine x, minus copy sine x times the derivative of x is equal to 1, all over x squared. So it's gonna be x cosine x minus sine x times 1 is sine x, all over x squared. That's it. Next example. If f of x is equal to ln x over x squared, therefore x squared times the derivative of ln x minus ln x times the derivative of x squared all over x squared to the power of 2. So it's gonna be x squared times the derivative of ln x is 1 over x minus ln x times the derivative of x squared is equal to 2x all over x to the power of 4. So simplify. So it's gonna be x minus 2x ln x over x to the power of 4. We can observe common factors, like x. So what remains is 1 minus 2 ln x over x to the power of 3. So that's it. Last example. If f of x is equal to 2x plus 3 over 2x squared plus 5x, let's find the derivative. So let's copy the denominator 2x squared plus 5x and then we'll multiply it to the numerator's derivative. The derivative of the numerator is 2 minus, copy the numerator 2x plus 3, then multiply it to the derivative of the denominator, which is 4x plus 5 all over 2x squared plus 5x to the power of 2. Then we'll FOIL it. 2x squared times 2 is equal to 4x squared. 5x times 2 is equal to 10x. Note that it is preceded by a negative sign, so we'll distribute it. So 2x times 4x is equal to negative 8x squared. 2x times 5 is equal to negative 10x. 3 times 4x is equal to negative 12x. Lastly, 3 times 5 is equal to negative 15, all over the quantity of 2x squared plus 5x to the power of 2. Then we'll combine common factors. So 4x squared and negative 8x squared will result to negative 4x squared. Next is 10x, negative 10x, and negative 12x. If we'll simplify that, we'll get negative 12x. Then copy negative 15 all over the quantity of 2x squared plus 5x to the power of 2. That's our derivative. Last but not the least differentiation formula is the derivative of other trigonometric function. Let's say the derivative of x is equal to the quantity of tangent x is equal to secant squared, then copy what's after tangent, which is x, then multiply it to the derivative of x. So secant squared times x, and the derivative of x is equal to 1. So it's gonna be secant squared times x times 1, which is equal to x. So that's it. Let's try another one. The derivative of x is equal to, and the quantity of cotangent x is equal to negative cosecant squared. Then copy x, so it's gonna be times x multiplied to the derivative of x. It's gonna be in parentheses x. Negative cosecant squared times x multiplied to the derivative of x, which is equal to 1. So negative cosecant squared times x is the same as negative cosecant squared x. Next example. The derivative of x is equal to, and a quantity of secant x is equal to secant x times tangent x multiplied to the derivative of x. So secant x tangent x times the derivative of x, which is equal to 1, which is still the same. So it's gonna be secant x tangent x. Next example. The derivative of x is equal to, and the quantity of cosecant x is equal to negative cosecant x times cotangent x multiplied to the derivative of x. It's gonna be negative cosecant x times cotangent x and multiplied to 1 because it's the derivative of x. So negative cosecant x times cotangent x times 1 is still the same. And that's it for our differentiation formulas tutorial. Thank you for watching.